Welcome to qnawire.
Okay, so we have the spectrum for 2-hexanol. And what we've got to do is decide what is the structure of this base peak in our spectrum. Now, the base peak is just the tallest peak. That's all that base peak means. It's not the molecular ion, it is the tallest peak. And when I look at the plot, I see that the tallest peak occurs at 45 m over z. This is like saying that we have 45 AMU to work with, atomic mass units, right? If we were to split this molecule, split that bond such that we had CH3 and a radical CH2 here, this would show up as a peak at 15 m over z, because that's 12 for the carbon plus 3 times 1 each for the hydrogen equals 15, right? So that's really, right, and then this would be 102 minus 15, because this whole thing together weighs 102, right? So this would be 87. Okay. So what we need to do basically is pick a bond to break this at and fragment it until we get something that weighs 45 AMU. Okay, so let's do that. Now, I have a good idea of what it is, and that's because I happen to be familiar enough with mass spectrometry to know that the carbons, where you've got OHs, those neighbors pop off a lot. So it's really common for that fracture to happen or for this fragmentation to happen. So let's take a look at this fragmentation. Would that help us? You know, it previously weighed 102, and this would give us that fragment, and this CH3 would pop off the methyl group, right? So that's like the same as what we had before, right? That's 15 for the methyl group and 87. We're looking for 45, so that fragmentation is not going to help us. So let's move on to the other fragmentation, where we break the carbon-carbon bond on this side, right? What would that give us? Give us this and that. And recall that there's just a single hydrogen here, right? These are radicals. They're positively charged radicals. Okay. Actually, one side will be neutral, but it's not super important. The idea is that the species that we actually detect will be a positively charged radical. Okay, so how much does this weigh? You know, I see a CH3 here. I see a CH here. That's a carbon, right? So let's say CH3 equals, that's 15 plus another carbon is another 12 plus this hydrogen, that's another 1 plus an oxygen, that's 16 plus another hydrogen, that's 1, right? So I see 45. And that's what we were looking for, right? We were looking for 45. So the fragment is then that is 45.